Hello everyone. My name is Sabrinah Yonell C, and I'll be discussing the my review on deep learning in phishing detection. So firstly, I will go through the outline of my review. So first, I will introduce the phishing and the advancements of phishing. Secondly, I will elaborate the two papers that I actually chose. And lastly, the advancements and improvements for this case. So, as we all know that the phishing is a crime that affects everyone, including organizations and governments, and even individuals like us. Email phishing is a typical type cyber attack that can have serious consequences, including financial loss, identity theft, and damage to a reputation. Nowadays, email phishing has become increasingly challenging to detect and prevent. Attackers constantly evolve their methods to evade detection by security solutions and law enforcement agencies. Um, each of us must be able to detect and prevent these attacks at scale if they wish to avoid victim at this threat. Since the COVID-19 pandemic, all transactions and life needs needed to be procured online, just like shopping and transactions, even in banking, as compared to doing so physically, which is like the usual ones. On the other hand, the growth of e-services expands attackers' opportunities to gain or misuse users' information, especially the sensitive ones, just like their names, phone numbers, identification, and credit card information. As a result, users face a variety of online threats and cyber attacks every day through different types, may it be from email, messaging via SMS, or URLs. So these are the papers that I actually chose. First, it's a paper that uses CNN, LSTM, and the combination of the two. Secondly, is a more generalized one, but because it uses CNNs, RCNN, LSTM, and BERT. So, on the first paper, the researchers actually make it into emphasis that the robustness of deep learning algorithms has encouraged researchers to propose many methods for dealing with phishing websites by extracting features for classifying URLs. Numerous methods that assist in detecting phishing attacks have been applied by using different, new, and known features such as their URL length, frequency of keywords, lexical features, and by incorporating new features. So, this research actually used the empirical method of performance of these three deep learning models, and they use select keywords for feature extraction. So, this is how the architecture looks like in each of the models, and these are actually being combined to do their own environment of the framework of the system. So yeah, in this section, the important details of the model's configuration are discussed. So there are four stages to it. The first stage looks through the features of the URLs which are obtained from the dataset. The second stage involves pre-processing, in which detection of null values and scaling values of feature selection, which contributes most of the target variable by using select keywords. The third stage is the training of three different models, namely LSTM, CNN, and LSTM-CNN, by building a deep learning approach. Finally, as the evaluation of the approach using a number of indicators to measure how the model performs in detecting phishing websites. And lastly, the classification of the web page URLs as the legitimate or phishing. So these are the sorry for that subtitle. This is actually the distribution of the data set. So it is actually crucial to choose an appropriate number of parameters to enhance the model's performance. So each parameter was selected based on the value that enhanced performance. One of the main parameters of the system is the age, which is considered as the number of iterations of training after the deep learning model is built and compiled, which is its value set is set to 50 epochs. And here's are some of the parameters that are actually being used by the researchers as well. So after the implementation, the results showed some level of improvement in phishing detection through the CNN algorithm since it had the highest accuracy at 99.2%, followed by the LSTM-CNN algorithm, which achieved 97.6%, while LSTM achieved 96.8% prediction accuracy. So here's some of the performance evaluations for this one for the each of the models. So yeah, excuse me for that. So however, the proposed system has some shortcomings. The model has not checked the status of the URL of the website, whether the website is active or not, which actually impacts the results. To overcome this limitation, the researchers actually propose to speed up the training process and improve feature engineering, which would then allow us to verify the website's state and improve training process accuracy. So now let's proceed to the second paper. So the second paper source detecting phishing emails using persuasion cues, specifically on gain and loss persuasion cues. One with relevant gain persuasion cues, second on the relevant loss, and lastly with the combination of gain and loss persuasion cues. The models were then compared to a baseline model that does not account for the persuasion cues. The results indicated that the models with relevant persuasion cues outperformed the baseline model by around 5 to 20% in terms of F1 score, which shows that the including persuasion cues in anti-phishing methods can effectively detect and block phishing emails. So the researchers actually use this as the main point for them to enhance more, and this is actually like included in their study, which is I did not actually see in other papers. So yeah, these are the deep learning architectures that the researchers actually use. So in CNN, they are actually useful in analyzing text-based data, such as the text of an email or the sender's address. They can extract features from the input data and be used as feature extractors or classifiers. Meanwhile, in BERT is a deep learning model designed to perform natural language processing tasks such as language understanding, translation, and text classification. This is particularly useful for email phishing detection because it can understand the context of the text, which is important for the text classification task. Nextly, the RNNs and the LSTM, they are well suited for language translation, sentiment analysis, and speech recognition tasks. They can maintain a hidden state that can be updated based on the current input and previous hidden states. This allows RNNs and LSTM to keep track of context and dependencies over time, making them suitable for email phishing detection by analyzing the text of an email and extracting relevant features. So these are some of the data set considerations of the researchers. They actually consider the size, diversity, the quality, and the relevance. Size because it is important to use a large data set in order to provide the model with enough samples to learn from. A data set with enough samples can help the model to generalize better to new and unseen data. The diversity. The dataset should be diverse with various emails representing phishing and benign messages. This can help the model learn more robust and accurate patterns for detecting phishing emails. Next, the quality. The data should be high quality with minimal errors or inconsistencies. This can help improve the accuracy of the model. And lastly, the relevance. The data should be relevant to the task at hand. For phishing email detection, the dataset should include a representative sample of phishing and benign emails like those on the model will encounter in the real world. So the researchers actually sourced a lot of open source data sets, just like the phishing data set which they actually got from UCI machine learning repository, and the benign data set from the N1 email data set, which is actually quite big because this is one of the biggest scandals in the US commercial industry. So the datasets were cleaned using the Python's natural language processing techniques. The implemented data underwent pre-processing steps to prepare the email text data before feeding them into the deep learning models. For the CNN, RNN, and LSTM models, the text data were converted to lowercase and stripped of special characters, numbers, and stop words using regular expressions. For context, these stop words are actually like the an, and the some of the um, pronouns. Pronouns? Yeah, pronouns. For the BERT model, the text data were tokenized using the BERT tokenizer from the Transformers library by truncating sentences to 512 tokens and generating input IDs and attention mass. These pre-processing techniques help reduce the noise in the data and enable the deep learning models to learn more effectively from the clean text. Pre-processing the email data was essential to improve the accuracy of the model by highlighting the key textual features and patterns for identifying phishing attacks. So, for the results, the recall of the proposed model was 98.78%, which indicates that the model correctly identified 98.7% of the phishing emails. For the F1 score, it indicates that the proposed model has a high level of accuracy in identifying phishing emails. These results indicate that the proposed model is a promising technique for detecting phishing emails with high accuracy. So for the RNN, we look through the precision of the model. So the precision achieved 98.57%, which indicates that when a model classified an email as phishing, it was correct 98.57% of the time. So recall measures the proportion of true positives, which is the emails classified as phishing, out of all actual positive emails that which is the emails that were actually phishing. The proposed model achieved a recall of 98.53%. In addition, the proposed model achieved an F1 score of 98.55%, which is also a high level of accuracy in identifying the phishing emails. For the LSTM, it achieved an accuracy of 98.89% of the test set, which is slightly higher than both of the CNN and the RNN models. This demonstrates that the LSTM could correctly classify most phishing and legitimate emails. Um, the precision of 98.87% indicates that the LSTM had very low loss positives, which rarely mislabels the legitimate emails as phishing. The recall of 98.86% means that the model successfully identified almost all phishing emails with minimal false positives. The F1 score of 98.87% reflects that the excellent balance between the precision and recall attained. Overall, these metrics show that the LSTM performed very well and is reliable in detecting most phishing emails while avoiding the false alarms. The LSTM's ability to retain the memory of the previous context likely allowed it to be better analyze the relationships of the email content. So, Lastly, the Burton LSTM model actually has a very low basis for us to for them to actually based on, but these are actually the performance metrics of the performance evaluation of the BERT and LSTM models to actually reference. So yeah, if you look at this combined, the LSTM is actually um, great in in performing the LST, I mean the detection of phishing. Um, Going back, like I actually forgot. I'm gonna add something for the LSTM, BERT LSTM models. It can actually be relevant that there's actually some quite of an overfitting happening, as you can see from the accuracy. I mean, yeah, that the accuracy and the loss, which is like the test is actually kind of like suspicious looking, but so yeah. So for the advancements and improvements of the study, so when I look at the other papers, I would like to like emphasize that from the first paper, they actually suggested to check the status of the URLs, which is this can actually be part of the data cleaning process, so that you can actually mitigate some of the links that are not actually active anymore, and that can um, be used to actually get rid of the other data so that it won't be part of the training anymore. So yeah. Secondly, we'll also enhance the training process by reducing the training time and improving the feature engineering in order to verify the state of the website and improve the training processes overall accuracy and present an approach that considers the web page content as well as the URL in order to detect phishing websites. It should be noted that a single security system alone cannot provide the complete security. It is also recommended to use email detection in conjunction with other security systems, just like firewalls and antivirus software, to enhance the overall security. In addition, there can also be future researches in deep learning and transformers, which is essential to improve the real-time detection of phishing emails. While effective on its own, the proposed phishing detection model can provide additional security when integrated with existing infrastructure like firewalls, gateways, and endpoint antivirus. The deep learning model can be deployed on email gateways to analyze incoming messages and flag potential phishing threats. Combining it with firewall rules that filter on sender reputation and domain blacklist can reduce the number of malicious emails entering the network. And email filtering can improve the signal to noise ratio for security operation centers to allow the analysts to focus on fewer high quality alerts. More advanced and enhanced datasets are required to improve the feature selection process, and research is needed in dynamic feature selection using deep learning models. So yeah, that is all for me, and thank you very much for listening. Bye bye.